Okay, see if I can do this correctly. All right. So for the first one on the left, domain is 0, 1, -1, 2, -2. No, actually, put it in order. -2, -1, 0, 1, and 2. The range is 0, 1, 2. The domain here is 1 and 4, and the range is -2, -1, 1, and 2. This one here, it's a function. Every input has only one output. For here, remember, I don't know why they didn't do this, but they should have done this. This is my input. This is my output, right? So notice that 1 has two outputs, -1 and 1, and 4 has two outputs, -2 and 2. So that makes it not a function. This might be a long video. Over here, same thing. And again, I'll put x and y, x and y, x and y. So my domain is all the x values, so -2, 3, 1, and 0. My range is 3. I should have put it in order, but 3, -2, 3. Notice that the 3 pre, so I'm not writing it again, and -2 again. So just that's my range. Well, if you find that hard to see, you can always do a mapping. So -2, 3, 1, and 0. -2 is 3. 3 is -2. Then 1 is 3. And 0 is -2. So is this a function? Yeah, every input has only one output, so yes. This one, again, the domain is all your x values. The domain is all your x values, which is 3, -2. 3 is repeated. Okay, there we go. And the range is all your y values, which is -2, 0, 1, and 3. Is this a function? No, because notice that 3 has an output of -2, and 3 again repeats. So 3 has two outputs, -2 and -1. So not a function. Guys, the sheet right here on top, take one each. I'm assuming you're here for soccer. Read the instructions, please. How many do you need?
3.
Okay.
See you later.
So next one here, domain and range. Again, domain is this guy here, right? This is your range, or input, domain, input, input, output, right? Input and output. So notice that the 1 has one output. Everybody has one output. 3 has one output, which is 4. 5 has one output, which is 4. It doesn't matter that 3 and 5 have the same output. That's okay. But 3 has one output, and 5 has one output as well. So again, this is, yes, a function. 3 has, again, so again, let me write domain here, or input, output. 3 and -2, 1 has an output of 0, that's okay. 0 has an output of -1, and 0 has an output of 0. So, again, this is my domain, right? Remember, this is my output, and not a function. Tables. Table 1. So -2 has an output -3, and again, look at your x values and make sure your x values have one and one output only. And I don't see any number repeating, so table 1 is a yes. Table 2, notice that there's a 4 here and there's a 4 here. So 4 has an output of -2 and an output of 2, so that this makes it not a function. Table 3, anything repeats on the inputs? No, so it looks okay. So every input has one output, so that's a yes. And 4, notice right here, that and here. 1 has two outputs, it's -1 and -3, and then 3 has two outputs, -2 and -3. So if that looks like a mapping, which is how I'm just going to pick those two numbers. 1 has this output and this output, and 3 has two outputs as well, so no. So if it's a yes, you can just write, hey, for every input there's one output, and if it's a no, you can write that there were inputs that had 2 outputs. For a relation to be a function, there must be one, right? There must be one output for each input. So that's what you write in here. Does each table represent a function? What is the domain in this range? So right off the bat, I can write, I'm going to be lazy. Domain and range, right? My x values, my y values. So remember, input is always your x, output is always your y. Let me do that, okay, over here. And I'm going to put a D for domain and R for range. D for domain, R for range. So look at the first one. 1 has only one output, 2 has only one output, 3 has only one output, so this is a yes, it's a function. B, 1 has an output of 1, which is okay. 0 has an output of 2, which is okay, but then 1 has another output of 5, so this is a no. X, well, everything here, so if that were to look like the mapping, right, it would look like this. 1 has an output of 2, 2 has an output, sorry, 1 output has an output of 0, 2 has an output of 0, so it's 3, so it's 4, so it's 5, so it's 6. And that's okay. Okay? So again, every single input has one output. Doesn't matter that they're all the same. So this is my input. This is my output. So this, yes, it's a function. 1 looks okay. Every input has an output, one single output, so 1 to 4, 2 to 3, 3 to 4, 4 to 3, that's okay. Red is rose, blue is sky, yellow is sun, blue is ocean. Okay, issue. Blue has an output of sky and it has an output of ocean, so this is a no, not a function. This one was a yes. A to little a, B to little b, C to little c, and D to little d. Yes, a function. Vertical line test. So this is the quick way of telling if a graph is a function, represents a function or not, is by using the vertical line test. So you can get a line, ruler, right? And then let's move this across the graph and ask yourself, right, in this case, that this line right here, right, the diagonal line, how many places is that diagonal line touching the red line that I'm moving across? So far in one place and one place only as you move from right to left. So if it's only one place, it's a function. Example 2 again, if you move that to the right, notice that that parabola is touching the red line in only one place at any given time. Here, you'll see the difference more clearly. If I stop it over here, that line's touching the red over here and over here. And if I move my red line and keep moving it, even at that point as well, or any other point, it touches the red line in two different places. So not a function, yes a function, yes a function, because it doesn't pass the vertical line test. Right? It's just a quick way. Find whether each graph, and again, same thing. Use that same line, great. So as you move this, do those points touch the red line in only one spot, which would make it a function. Now notice, hey, right here, those two dots touch the line at the same time. So right off the bat, not a function. So that's a no. This one, good. But when I get to this point, oh my God, it touches the red line in 4 spots. Definitely not a function. This one is a function. Touches the red line at only one spot at any given point in time. Not a function, because look, when I get on top, the whole line is touching the red line. E, so far so good, but when you get to this spot, this line right here, right, the vertical line touches the red line in more than one spot, right? And then finally this one, good. That line touches the red line in only one spot at any given point in time. So, not a function, yes, no, yes, and a no. All right, pretty easy. Oh, there's more. And then we did that in class, so yeah, let me just finish this. Okay, so again, vertical line test, vertical line test. Obviously, I know it touches the red line in more than one spot, right? This is a yes. That diagonal line touches the red line in only one spot. As you move the line from left to right, and again, only at any given time in only one spot. So yes is a function. This is also a function. That parabola only touches the red line in one spot. This one is not a function, of course, right? If you think about it, it touches the red line here and touches the red line here at the same time, so not a function. And the last one, let me just put it over here, and you'll see that it touches here and here at the same time, so not a function. Okay, so this was a no, this was a yes, this was a yes, this was a yes, this was a no, and this was a no. Okay, so vertical line test comes in very, very handy when you have graphs. All right, so we'll use the graph for the bottom. Let's do the bottom since I'm. So doesn't pass the vertical line test, so this is not a function. Passes the vertical line test, this is a function. Doesn't pass the vertical line test because it's touching in two places, right? The red line touching the red line in two places, so not a function. And this is just same thing we had previously. It touches the line in two different places, so not a function. So no, yes, no, and no. Table. What's the domain? Well, this is the domain. I'll put a D here. This is my range, it's all here, that's the domain, this is the range, this is the domain, this is the range, right? Is it a function? Well, let's see. For 1, I have the output of -3, that's okay, this is okay. But then again, 1 has an output of 3 as well, so this is not a function because the input 1 has 2 outputs, -3 and 3. This one, 0 is to 2, that's okay. 3 has an output of 1, and then 3 has an output of -1. So again, not a function because the input 3 has 2 outputs. -4 has an output of -4, -1, -4, 0, -4, 3. This is a function, yes, because each, right, you can't look at whether they have all the same output. That doesn't matter. It matters if we have same input having different outputs. Sorry, more than one output. This one is a yes, and then this one passes the vertical line test. So definitely a function. If you move it around, notice that that pink line only touches the red line at one in place at any given time. Okay. All right, so that's that video. Oh, and there's more at the bottom here. And again, you can do the vertical line test. For this one, just move it around and notice that it doesn't matter. As I move that red line to the right, it touches that up and down curved line in one spot at any given point in time. So that's a function. This one looks like a V, right? So the V touches the red line in only one spot at any given point in time. That's a function. And then this one's a little tricky, right? Because there's open circle and closed circle. So when you're right on top of those two circles, it only touches the red line where it's shaded on top. But here where it's open, it doesn't touch the red line because there's nothing there. So this, good. Even when it's on top of those two circles, remember one is shaded, the other one is not. So it's only one point that's touching and you're good for the rest. So this is, so again, this was a yes. This was a yes. This is a yes. And this one is sort of like the one we just did where when you have these two, and I think that's an open circle from what I'm looking at and shaded at the bottom, so that's good. This is good. Whenever there's two circles, one on top of each other, if they were both shaded, then this would be a no, but the top one is unshaded, so this is a yes. There's only one point touching the red line at any given point in time. And that we did in class. So that's okay. I think we can